Taylor's book. I salute always the Taylor's book all the time. Very nice book. I always appreciate his wordings. I may justify them. I may justify them. An event is defined as the instantaneous effect of the termination of an operation.
Yeah.
So termination of an operation means maybe the operation was in a static state. Okay,
Yeah, in some scenario that could be
that could
termination.
be operation was in a static state. That means in the zero state. Nothing was nothing was happening. Okay,
Yeah. In the start of a phase,
and
yeah.
suddenly, yeah, you give some input and it starts working.
Right.
So the termination of an operation means termination of the static state, and
Right.
some dynamic state started got activated. So that can be the event.
Yeah.
So something was static, you gave the input,
Yeah.
and the dynamic state initiated. So
Initiates.
that instant of time, when the staticness got over and dynamism got started, that is the event. Event occurs at the instant of time. Okay,
Yeah.
you started writing the code at 4:15, so that is the event.
Yeah.
Okay,
That is an
okay.
initiation of activity. So also it can be considered as an event. Yeah. So should I proceed further, sir?
Yeah.
Yeah. So let's say, I guess sir have explained it very well. So I'll I'll explain it very shortly through this image. So user interacts with the page. First, he interacts with the page, and according to his requirement, he performs some operation. Like he'll be clicking on some button or providing some input. Then the event occurs, and in response to that occurrence of event, some piece of code will run, like some function will be called, and in that function some code will run, and in response to that code, the user interface page will updated or be modified. So that is a scenario of event. So coming to next slides, what is connectors? So like all of us are talking about connectors since the start of this class. So we have discussed enough of connectors, so I'll be going shortly. So connector performs and regulates interactions between components, and it couples many components together to perform the transfer of data. And connectors are connectors can be simple or can be very complex, like like it is showing in the diagram. Connectors can be complex, like we can build some connectors using multiple kind of services like communication coordinations. So these will be considered as a composite or complex connectors. Okay, so a few more description about the connectors. These connectors model the static and dynamic aspects of the interaction which occurs between the component interfaces. So there could be a static interaction and there could be dynamic interaction as well between the components. So these connectors handles both of these aspects. Okay. So what is the difference, like what is the main difference between components and the connectors? So components can be both application specific or application independent. But the connector will always, or most of the time, it will be application independent. So that is the main difference between component and the connector. And connectors are not usually visible in the code. Like for components, we write a lot of code, so we can directly visualize the components. But connectors would not be directly there. There would be a kind of linkage between modules or connection across the components. So This is another difference between connectors and components. So these connectors play four types of roles, as we have already discussed, like communication, or they provide four types of services like communication, coordination, conversion, and facilitation. Okay, so now coming to event-based connectors. So as I have already said, it is one of the common composite connectors. Now in this event-based connectors, these connectors are very much similar to procedure call connector, as they model the flow of control between the components. Thus, they provide the coordination services. As I have just said, the connectors provide four types of services. So this event-based connector provides few services. One of them is this coordination service, as they model the flow of control between the components. Okay. So the message which an event contains can be a description of event, or can be a description of multiple events or a pattern of events. Okay, so the message connectors carry between the components, this can belong to a single event or to a specific pattern of events. Okay, coming to next slide. When an event connector identifies the occurrence of an event, so when an event occurs in a component and the connector gets to know about it, it creates and generate message, or it creates or generate message, which we generally call a notification. Like it will generate notification to all the components, which to all the components who wants to communicate with this current component who is producing this event. Okay, so the connector helps other components to notify them that this particular component is producing some event. If they want to communicate with this component, they'll get to know about it through the connector, through this event-based connector. Okay. Now, the content of an event message, the event message, the content of event message can be structured in two ways. This message can be of this message can be of type this mess I'm sorry, I'm fumbling a little bit. So this event message can contain information about the event, like what time this event occurred, at what place the component was in which this event was occurring, and the other information about the application. So the event message can be of two type. Okay, one could be of containing information about the event, like at what time this event is occurring and what place this event occurred, and the other type can be of application specific, like in what kind of application this component is used, where this event is occurring. Okay, so the example of this type of connector is GUI events, as we have discussed in the starting. These GUI events occurs in our application, and the event-based connectors are heavily used in these kind of application where these GUI events occur. And some events will be there, like page faults, which will be caused by the hardware, and some events will also be there that would be which could be occurred by the software as well. So now let's discuss about the event-driven architecture, like how these event-based connectors are used in the event-driven architecture. So coming to this event-driven architecture, we have few elements like the event itself and event producer, like the component which will be producing the event, event consumer, the component which will be consuming the event or will be accepting the data using connectors, and another element will be event processor, which will be processing the data. Now, this event-driven architecture creates, detects, consumes, and reacts to event, because in this architecture, we'll be discussing about events all the time because events will be occurring, a lot of events will be occurring in this architecture. So some common concepts in their architecture includes these publishers, subscribers, that is also consumers, and sources and sinks. These will be some common concepts in this architecture. Now, what will publisher do? Publisher is the component that captures the event data, and if required, it will store the data in some repository. Okay. And now coming to the subscriber part. What is subscriber? Subscriber is the component that will consume the data or respond to an event. Like in response to the event, it will be needing some data. So it will consume the data and accordingly respond to that event. Now, what are sources? Sources are where the data originates. Like we can say components, sometimes components can be considered as a sources. And what are sinks? Sinks are the destination where subscriber sends the data. Like after consuming the data, subscriber will process the data and respond to an event, and at final it will sends the data to destination. Now we will understand all this theory through this diagram. So as I have discussed few elements like event producer, consumer, subscriber, and sinks. So all these are shown in this diagram. We'll discuss it. So event data will be produced through sources, like some component will cause the event to occur and then data will be produced. Okay. So publisher will capture that data and now store that data, and publisher will store that data into some event data store. As I have already told you that publisher will capture the data first, and if required, it will store this data. Now the subscriber will get to know about this data through connector, and it will consume this data and it will respond to the event. Now if another publisher, if suppose if there is another publisher which requires this data, the data which this, I'm sorry, yeah, the data which the first publisher stored in the event data store, if another publisher requires this data, it will collect from here, and another like this publisher will again store it into another data store, and from there subscriber will collect it and process it, and finally this data will be sent to this destination. These sinks, file system, apps, these are the destination, final destination where this subscriber will send this data, and this process will go further. So I have described few information below the diagram. This diagram represents a common event-driven architecture pattern in which event feeds action in the application and repositories. The event is generated by some action, like user will be performing some action, no? Like pressing some button or giving some input. So this event is generated by that action and fed through a connector. The connector will carry this information which event will be containing. So this publisher, this subscriber, all will be using this event-based connector to get the information or to pass the information, which is data in here, the event data here. So this information will be fed through the connector to the next coming component, like it could be publisher or it could be subscriber. And if required, this data can also be processed by using some stream processing platform. And then finally, the result will be delivered in the repository. That repository can be sinks like database, or it can be any file system, or it can be another component we see. So this will be finally delivered to the repository. Now, few more points about this architecture. We can both create and respond to a large number of events in the real time, right? User can create any number of events and a component can respond to many events, right? So it is a very particularly well suited architecture. I'm sorry, it is a well suited architecture for loosely coupled software such as microservices. Like the user can create any number of events without worrying about how it will be consumed by the subscriber, or subscriber can also consume any number of events without worrying how many events are being produced. So this architecture works very well with unpredictable non-linear events. So they are very versatile. Like as I have already told you that event can be generated at any rate and can be consumed at any rate. So now let's discuss about some constraints. There will be some constraints in this architecture. One of them is asynchronous communication. Like producer will be generating a lot of events at any moment, and consumer can be notified of these events at any moment. Like there will not be any kind of synchronous communication. This is the asynchronous communication. Another constraint is relationship. Relationship can be one-to-one, can be one-to-many. It depends on the events are being generated and events are being consumed by the consumer. So it can be one-to-one and it can be one-to-many. Now let's discuss about some advantage of this architecture. First advantage is decoupling. So event producer does not depend on the consumer, right? It can generate any number of events at any time, and nor the consumer will depend on producer. It can also consume any events according to its requirement. Another advantage is timelessness. Like events are being published without any need of wait for the termination of an event. Like a user can simultaneously create two events without waiting for the completion of an event. Like it can provide some input to the user interface, and just after that it can click on a button as well without waiting for the completion of that first event. So this timelessness is another advantage of this architecture. Third advantage is asynchronous. As we have already discussed, this communication is asynchronous type. Like the publisher will not be worried about consumer, and the consumer will also not be worried about producer. So now let's take an example, like how this asynchronous communication happens and how this event-based connectors helps to components to communicate with each other in a asynchronous manner. So let's take this admission process example, which all of us have known about. Like, so in a college admission form, student will be entering some personal details first, and then will be filling some academic details, and after that some course details, and finally the application will be submitted. So this information will be carried out through these event-based connectors. We'll be understanding it with the help of this example. So here the first component is personal information. So user will be providing some input, which can also be considered as an event. Like he will be providing some input, so that will also be an event. And after providing this information, he will be clicking on the button save and continue. So this will act as a connector here. So it will carry all the information which user provided in the first place, and the next component will respond to this event, and it will consume this information which the first component provided, and it will process this information, and accordingly the user interface page will be updated, and user will create more event here. Like he'll be entering the academic details here, and after entering all the academic details, he will again be clicking on the button that is save and continue. So again here this save and continue button will be acting as connector, this event-based connector. It will be carrying all the information which this previous component had, and the next component courses will respond to this event, and consumes the all the information which is about academics and the personal as well. And now be user will be creating more event here in the courses component by entering more details about his courses details. And finally, it will be clicking on again save and continue button. So this save and continue button again will act as a connector. It will carry all the information to the next component. So next component again will consume this information and the user interface page will get updated. So likewise, the more components will be consuming all the information from the previous component using this event-based connector. So this connector plays a very important role here. It helps components to communicate with each other. So that is how this event-based connector is very much important in the architecture. Now let's talk about some services, what kind of services this event-based connector provides and what dimension it provides and what subdimension, what values. We'll be discussing about all these. So through this diagram, I'll be explaining. So cardinality is a dimension. This event connector provides few dimensions like cardinality, delivery, priority, synchronicity, notification, casuality, like this dimension. So we'll be discussing one by one. Cardinality, which has the subdimension. Again, this cardinality has some subdimensions like producer, observers, event patterns. So this cardinality will be having some subdimensions like producers, observer, event patterns. As we have discussed now, some component will act as a producer, some component will act as observer. So this will be the subdimension of the cardinality. And the another dimension is delivery. So delivery dimension will be having some values like best effort, exactly once, at most once, and at least once. Now another dimension is priority. Priority priority is having few more subdimensions like outgoing, incoming, and likewise you can see all the dimensions in the diagram and all the subdimension as well and all the value as well. So I have written in the context here, so you can go through it. Now from this diagram, we can see that dimensions such as casuality, cardinality, mode, and synchronicity plays a very critical role in this mechanism. Like what will be the cardinality of it will be one to one or one to many. It can be anything. No? What will be the like the components will be communicating with each other through the synchronous mechanism or the asynchronous mechanism. In the example I have discussed, the communication was asynchronous. Okay, so there could be the synchronous communication as well. Now event connectors are found in distributed application as well, which requires asynchronous communication. Like in our example, it was the asynchronous communication. An example of this type of architecture can be an windowing application. It will be like X windows in the Unix, where GUI inputs act as an events that will be activating the system. Like the user will be providing some input to the interface, so that will activate the system. And finally, some event like interrupts, page faults, or traps. These page faults and interrupts, these will be the event which will be caused by the hardware part, and the some events will be caused by the software as well. Like the user will provide some information, like I have discussed in the example. Now, some user will provide the personal detail and academic detail. This kind of event will be caused by the software, and these traps, these page faults, these interrupts, these events will be caused by the hardware part. So that's it, guys, from my side. Thank you.
Good. I was interested to hear something about three things: event handler, event loop, event flow layers.
Okay.
In any event-based connector, these three things play a very vital role. event handler, event
Yes.
loop, and event flow layers. So something I was interested to hear you somehow.
Yeah,
Tell
it,
us. Yeah.
I would like to justify it with the example. Like some component will be acting as an event handler. Some component will be acting in this diagram. Where is that? Yeah. Some component will be acting as the event producer. So I could have considered all these, but the content would be like very much big. So
Anyway, you note down and tell in
yes,
the next.
I've written it down. Yeah.
Event handler, event loop, event flow layers.
Yeah.
Okay. Yeah,
Hmm.
these three things play very vital role.
Right.
Okay. Check it. Okay.
Okay, sir.
Anybody? Rishabh, Soni,
Sir. Yes, sir.
if you have any doubt, you want to
Sir,
learn something more from your good friend Jitendra Gura.
sir, I would like to write something in from slide number 7. Can you
Yeah.
please?
Yeah.
Yeah.
Go back.
Yes, sir. The elements are the
Yeah.
event person.
Yeah. Tell me, Rishabh.
No, I was just wanted to write.
All right, all right. So there will be more elements, but these elements will be more important, like event itself, and then event producer, event consumer, and event processor. These elements will be important elements. Like we'll be uh, encountering these elements more. This is the general diagram. Like event producer will be producing the event, and then it will be processed by the event processor, and then finally event consumer will consume this event, like the data in the event.
Okay. Okay.
Anything else, guys?
Anyone else? Mahendra Kumar Sharma.
Yes, sir. Hello. Yes, sir.
Why do you
Hello.
come? Why do you come only 14 minutes late all the time? महेंद्र शर्मा, आपकी पूरा आदत बन गई है. आप whenever you feel like you join, you don't join, you come late. You have been identified as a habitual problem maker. This is the wrong impression I am developing, Mahendra Kumar Sharma. You should interact. You should be the first person to join. I never see you joining for the first in the initial time. Never see. You are only led by 14 minutes today. Every day you are a habitual latecomer. What type of good image you are building up, Mahendra? You are from such a good college. Why are you ruining yourself? Such a good college. This is the image of a good college, right?
No, sir.
The image of a good college, right?
No, sir.
This is the image of a good college. You are hating others because all are from bad colleges. You are the best boy, a boy from a best college of the country, and you
No,
are
sir.
becoming the good example for others, right?
No, sir.
No, sir, but every day, yes, sir. No change with your attitudinal problem. No change. Only more than a month went up, and I didn't find any attitudinal change in your mindset. Okay. You don't have any questions because you are having something else in your mind. That's the whole problem. And anyway, so we'll close down. Deba. Okay. If nobody has the question, why shall I push you from the back? I don't want to kill my energy by pushing you from the back. Okay. Deba is there. Deba is not there. What happened to him? He's in a village. He's in a village now, so he has some net problem. Let me see further. Acha, can you open the slide number 19 of, can anybody open, share slide number 19 of chapter 8? I'll tell something.
Yes, sir. I have these slides. Should I share?
Yeah. Slide number 19, that big
Yes, sir. Yes,
matrix.
sir.
Okay, okay, sir. Deva sir,
Deba
you
is
share
here.
it.
Deba Bhaiya has come. Deba? Not yet. Yes, net problem. He stays in a small village. Okay, slide number 19. Please share. I'll talk with you. Therefore, I'm following further like I'm getting.
Yes, please, sir. Yes, sir.
Slide number 19. Please share.
Yes, sir.
Slide number 19. That big matrix.
Sir, I am online.
Who? Debo? No, who is online?
Sir, Debo sir is there.
Debo said is that. Okay.
Yeah.
Okay. Debo, you open that slide number 19. Khulo. Okay, khulo. Oh, he is not able to. Oh, after you close down and again you open. Again you open. You close it down and again open. Anybody else in the meantime open slide number 19 from chapter 8. That is, Debo is having some problem in net. Got it, Debo? 19. Next. You go back. Who is sharing? Who, Debo? This one.
No,
This.
sir. Jitendra Gora, sir. It's me.
Jitendra Gora,
Sir,
you.
no, sir. Sir, what's your
Okay, sir. I'll stop.
You
Sir.
please say to them the concept of pop-up.
Okay. Just let me speak up.
No, sir, team re, sir. Team re.
Okay.
We are fixing the.
Okay. Just listen. What I mean to say is,
Okay.
how many of you have separated each block out? Could you understand my language? Students, could you understand my language? Rishabh, आपने मेरी language समझ में आई? Rishabh, सुनिए.
Yes, sir.
मेरी language समझ में आई?
Yes, sir.
क्या मैं बताया?
Sir,
There are
separating. Sir. Yes, sir.
8 rows and 8 columns. Okay.
Yes, sir.
For each row there will be 8 blocks, right? For each row there will be 8 blocks, right?
Yes, sir.
There are 8 rows, 8 columns. So how many blocks will be there?
64.
आप निकाल करके खुद देखे हो. 64 से ये तो हो गई करीबन एक हफ्ता की बात. लास्ट शायद थर्सडे को पढ़ाई हुई थी. 64 से कितना आप निकाले हो? करो, कोशिश करो, तब जाके पता चलेगा ना कैसे क्या इंटर रिलेशनशिप बनती है.
Yes, sir.
How the interrelationship occurs between different types. तब जाके
Yes, sir.
पता चलेगा. ऐसे जब भैया पढ़ा देंगे, आप घर में खराटे मारोगे तो मुंडी का ऊपर सब टेंजेंशियली निकल जाएगी. करोगे ना. 64 है यहाँ पर. 64 है. क्लास में लड़के हैं कितना? 16 करीबन मान लो. 4 तो मैं महेंद्र को गिनता नहीं हूँ. तो मान लो कि there are 16. तो I will assign 4 to each one. Okay. So next time ना 4 ज्यादा कम ही हो जाता है. नहीं, मैं I will identify 8. I will identify 8 and 8 students I will identify for each type. 8 blocks you bring out and display in the next class on next Monday. माने 3 तारीख को. ओके. मंडे कितना तारीख है? मंडे है 2 तारीख. मंडे 2 तारीख. 2 तारीख को 8 students will display 8 blocks. Each one 8 blocks, right? Could you understand my language? For 8 rows, there will be 8 blocks for each row. So there will be 64 blocks in total, as Rishabh told. So can you do that? So the first one is Rishabh. The first type. Okay. Okay.
Yes, sir.
Okay. First one is procedure call, right?
Yes, sir.
Second
Interaction
one,
of that means sir interaction of procedure call with all other 8. Yes, sir.
या सारे 8 का साथ कैसे ये इंटरेक्ट करती है, राइट?
Yes, yes, sir.
आप एवरी सिंबल को एक्सप्लेन करोगे,
Yes, sir.
हाउ ईच सिंबल वर्क्स विथ सम एग्जांपल का साथ, ठीक है?
Yes, sir.
एग्जाम्पल नहीं देने से पता नहीं चलती है, ठीक है?
Yes, sir.
तो ऋषभ को मैंने दिया मंडे के लिए द फर्स्ट वन क्या है, कौन सी टाइप बोलो?
Procedure call.
प्रोसीजर कॉल। ऋषभ को आप 8 डायग्राम एक्सप्लेन करोगे, ठीक है?
Yes, sir.
सेकंड क्या है, कौन सी है? सेकंड बोलो।
Event. Event.
अभी पूरा बताया, ऋषभ का बाद गोरा। ओके जितेंद्र,
यस सर।
आप इवेंट पर तो ज्ञान ज्यादा है, आप सबको ज्ञान दो, ठीक है?
ओके।
थर्ड क्या है? कुछ मेरे को दिखता नहीं है, छोटा बहुत फॉन्ट है यहाँ।
Sir, data access. Data access.
Data access, let me give to Nirmal Panda. Okay, Nirmal.
Yes, sir.
You see some examples. Explain 8 blocks. Okay.
Yes, sir. Okay.
Okay. Up 8 blocks from the row wise and 8 blocks in the column wise. You check it. Okay.
Yes,
Row
sir.
wise and column wise. Okay.
Okay.
How is it different? How is it same? Check करके you have to show it. Okay.
Okay.
Okay. Fourth one क्या है बताओ निर्मल? Next one is
Linkage.
linkage. Okay. Linkage Siddharth. Siddharth to try.
Yes, sir. Sir, I'll try, sir.
I'll try to try. I always confuse.
Yes, sir.
Always. सिद्धार्थ राउतराय is linkage the fourth one. Linkage के बाद सिद्धार्थ बोलो next one, fifth one is yeah.
Sir, arbitrator, sir.
Arbitrator is the person who takes a decision. Arbitrator. Okay. Something is called decision maker. Some sort of decision maker. Arbitrator. Okay. Arbitrator connector will be explained by 8 Shibam Dalmia. Shibam, he was absent yesterday and today also. इसका मैंने पूजा खत्म नहीं हुआ। राकेश कुमार बिहार से। राकेश।
यस सर।
आप आर्बिट्रेटर, आप कैसे डिसीजन लेते हो आप बताओगे, ठीक है? राकेश कुमार, it helps you give a decision how it works.
Okay.
Arbitration. Okay.
Okay, sir.
Okay. राहुल साहू आर्बिट्रेटर के बाद क्या है? राकेश बोलो, आर्बिट्रेटर के बाद क्या है?
अडेप्टर।
हाँ, तुम्हारा नेक्स्ट वाला भाई है ना ये, अडेप्टर है। राहुल साहू।
यस सर।
यस, राहुल साहू, आप देखो कैसे अडाप्ट करते हो, ठीक है? How the connector adapts, we explain with little bit of example and all the 8 blocks row wise, column wise. Okay?
Okay, sir.
राहुल साहू 6 नंबर गया। 7 नंबर राहुल, तुम्हारा जुड़वा कौन है नेक्स्ट? क्या, कौन सी कनेक्टर? तो
Sir,
small letter.
distributor,
Huh?
distributor connector, sir.
Distributor connector. Distributor connector. I will give to whom? I gave to Somu or not? Somu is sleeping or what? Somu, why you are not telling sir? Give it to me.
Yes, sir. Yes, sir.
I am giving to you distributor connector. Okay, Somu.
O- Okay, okay, sir.
Okay, you give some example. Okay.
Okay, sir.
ओके प्रतीक जायसवाल अभी तुम्हारा खत्म हुआ दशहरा की नहीं प्रतीक जायसवाल
Over, sir, over.
दशहरा खत्म
Yes, sir.
आज इसीलिए खत्म हुआ तो इसीलिए 8 मिनट लेट में आया मस्ती चली रहा था Be
I thought,
careful.
sir, I
Why
joined
you think?
earlier.
why you think तुम्हारी ये आंसर देने की जो आदत और पूजा में मस्ती मारने की जो आदत तुमको डुबाएगा आदत को सुधारो यू कैन तुम्हारा अच्छे अच्छे दोस्त है जो सब वो लोग पहले ही जान करते हैं आदत को चेंज करो मैं मस्ती मारूंगा है आदत जो है कचड़ा आदत एनीवे प्रतीक जायसवाल प्रतीक कौन सी तुम्हारा बचा द 8th वन
Stream,
है
stream connector.
स्ट्रीम का बहुत अच्छी एग्जांपल है you have to explain it be a good boy प्रतीक okay change your mindset nothing
Yes.
is ये सब मस्ती भागड़ा ये सब गारबा ये सब बेकार don't kill your energy be a good boy okay प्रतीक ये सब मंडे को मैंने रख लिया मंडे को A8 आप निकाल करके 8 ब्लॉक्स रो वाइज 8 ब्लॉक्स कलम वाइज आप दिखाओगे ठीक है so I have given because connector plays the most vital role in any architecture it plays the most vital role so I want each student should be very thorough about this part connector the different dimensions sub-dimension values all these things you should be very clear it plays the most important part okay Debo is there or gone oh, his net is giving a lot of problems Debo what is happening to him okay so we will is he gone or what
Sir, you are muted.
Devabhaya is having some problem in the net in his village. He remains in a little bit remote village. So he is having problem today. So I am taking the class. Okay. Let me share. I don't know how to share. All this thing. They do the job. Okay. Share content. I am sharing. Browse. I am sharing. Upload from my computer. Okay. Devabhaya is not able to connect today. I'm sharing here also some problem. Slowly it's getting uploaded. It's a modeling concept. How to develop a model for the proposed architecture. अच्छा और तुम्हें चेष्टा करो okay. It's taking time to upload. Some net problem, it's taking time from my system. To share it, it's taking time. I don't know. It's a bit slow. I was thinking to take the class. Very slow to share the slides. Let me open the slides. If at all I can open the slides, I can tell you something. Introduction to modeling. Okay. Okay. You open your slides. Dear students, you open the slide number 3 of chapter 9. Okay. Are you able to hear me? Are you able to hear me?
Yes, sir. Yes, sir.
You open in your system chapter 9, slide 3. My system is also, I don't know why I'm not able to share. It's taking long time. It's taking long time to share.
So do we need to share it or just open in our laptop?
Okay, you one who
So
who is
Pratik, sir.
Pratik, you open then share. If at all you can share, then fine. I'm getting stuck up. You open chapter 9, okay? Anybody opens chapter 9, we'll see. I'll just tell a little bit for coming 10 minutes. I'll tell, then I'll move out. Yeah. Yours is faster. I don't know why.
So first of all, you need to open it in your desktop or laptop. Then you can
Okay.
easily change the window.
You can easily change the window.
Yes, sir.
Oh, yeah. That changing window, I'm not very good professional because these type of new concepts, I'm totally new to all these new concepts. Anyway, just you make it full screen. You make it full screen. That slideshow.
So is it visible?
Not yet. The slideshow has not yet come. F5 or something, or sit on the full slide. Okay, leave it, leave it. It is taking time. Honestly, a lot of time we killed today. Okay, let me. You cannot make it slide, so you cannot make it bigger. No, no, yeah. No, bigger, little bit bigger, little bit bigger. You are, oh,
Wait, sir, wait.
wait, sir. Okay, wait.
Yes, sir. Now is it visible?
Yeah, it's visibly, but you can make it bigger, then fine. Yeah, fine. Ooh. Yes, leave it. Okay, leave it. Stop. Don't make any change. Okay? Okay. So what is an architecture? We have seen something. That architecture is some sort of decision. Principal design decision, PDD. It's a set of PDD, principal design decision. You are making some decision, and on the basis of the decision, you are going to develop your software. You got to just think of that bank consortium, one page write-up. That is the input in your hand only. So from that one page English write-up, you want to develop a large software for whole world consortium. How? You have to understand each word, identify what are the objects, what are the classes, what are the attributes, what are the operations, what are the methods, how the messages pass between the classes, how the invocations occur. So you have to understand it. Then make a decision. What I will do. What are the principal classes? So you take a decision. So architecture is nothing but a setup. It makes a display as well as a write-up. You are making a class diagram, and under the class diagram a write-up. Nirmal Panda, I was very unhappy because you didn't show a good write-up. So every diagram has to be supported by some explanation, by some write-up. So the decisions, whatever you take, they are to be portrayed in the form of some sort of display or some sort of picture or diagram, and a write-up to justify the diagram. Okay? Of what? Of your design decision. What type of decisions you are taking for proper design of the solution. The bank consortium, the bank manager has given you a task. You want to design. Design means plan effectively towards solution. That is design. Design is at the planning stage. Then you write a code and you see that it works and deliver it to the client who has given you the task. So before you go for the implementation or coding, you make a plan for an architecture. So architecture is nothing but a design decisions which are very, very principal in nature, very important, principal ones, the most important ones. The unimportant ones you ignore. You try to not give more emphasis on that. So architecture is a display of principal design decision which are made about a system, about your bank system. What are the decisions you are taking? So, taking a decision, we consider certain models. Certain models we consider. An architectural model is an artifact. Artifact means some sort of object or objective, artifact, that captures some or all of our design decisions. That architecture that captures all of our design decisions that comprise a systems architecture. So with that model, we want to capture all our decisions, design decisions. Architectural modeling is the reification and documentation of those design decisions. So that model is the reification, is the display, and that is a document. Nirmal, you see the documentation, that should be proper documentation of this design decision. So whatever the decision you take, you have to make a document of it. Documentation, proper documentation. Okay? How we model is strongly influenced by the notations we choose. So what type of notations we choose, our decisions are strongly modeled. So what is the notation? Here the word notation comes. Notation for role, notation for port. These help to display our decision. Okay? An architectural modeling notation is a language or means of capturing design decision. With the help of this notation for component, it's a rectangular block. A connector is some sort of connecting path between components. So that helps to explain our design decision. So with the help of the notation, we explain our decisions. Okay, next. Pratik, next. So what type of model we will pick for what type of problem? How do you choose what to model? For what type of problem, what type of model we will choose, how it is influenced, we have to decide. Architects and other stakeholders must make critical decision. They must take any critical decision, any sort of important. Critical means any sort of decision which is very important, critical. What architectural decisions and concepts should be modeled? So what are the important things should be modeled? They should identify. At what level of detail? So the model, as I told in the use case diagram, you draw the 0 level diagram, then go to the level 1, make it more detail, level 2 more detail. So at what level of detail? The initial is the context use case diagram. Then you go to the next level, make it more detail. Next level 1, level 2. So at what level of detail? With how much rigor or formality? How rigorously? Rigor means how rigorously you develop a model for the decisions you take. How rigorously. I was debating, you were debating, the arrow should be this use case to that use case. It should be arrowed or non-arrowed, or in which direction the arrow should be drawn. So that is rigorously you are checking, rigorously, so that there should not be any error, because based on that diagram you are going to write the code. Looking at the diagram in your left hand side, in your left hand, your right hand, you start making the code. So left hand is always, you are looking at the model, what model you have developed, what rigorously you have drawn the arrows from one use case to other use case, how from one actor to the use case, how. So that is in your left hand. That is your guide. Looking at the guide, you write the code in your right hand. How rigorously. So it has to be all the time. I tell that this diagram has to be all the time perfect. All the time perfect. Based on this, you write the code. Okay. These are the cost benefit decisions. Cost, a lot of cost is involved in drawing the model. What type of model you are doing, whatever rigorously you are doing. So a lot of cost is involved. It's a very difficult part to develop a right model. So based, if you draw it correctly, then only the benefit is your coding will be done correctly. All the time people ignore these diagrams. They start writing the code. Then they don't get the benefit. The code is erroneous. The code is erroneous. So cost is involved. Developing a model is costly. But if you bear the cost, then only you get the benefit. You don't have any choice. You don't have any choice in your hand. Okay, the benefits of creating and maintaining an architectural model must exceed the cost of doing so. So a cost is involved. So you have to justify why I need a good model. How does it help me? In many industries, they just ignore, they don't bother, they just start writing the code. A lot of cost is involved to make analysis. The project gets delayed. While making all this analysis, the project gets delayed. So it's a costly thing. The project manager will never like to give so much of time in making, giving so much of effort for the model. But if you don't do it, there is every chance of error in writing the code. Every chance. Code will be erroneous. Okay, next. Next, Pratik. So in your problem, you identify what are the, I always tell while identifying the use case diagram, what are the important scenarios? What are the important scenarios or the concerns? What are the important concern 1, concern 2, concern 3? So these are the important scenarios or the concerns. Based on these important ones, you build up the use cases, right? Stakeholders. I told there are stakeholders for any software development from the user side, from the developer side. User side who is the end user, who needs the right software for his problem. He gives order to his manager. So manager is the financial boss. So manager is involved. Then manager, he catches hold of any developing house manager like Infosys or any Oracle or any developing house. So another manager of the developing house is involved. Then developing house manager, he catches hold of the architect. Then architect catches hold of the developer. So at least 5 persons are involved in the whole software development process. They are called as the stakeholders. They take the stake. Stake means responsibility. All the cost involved, time involved, all the stake. So there are the minimum stakeholders for the software development. Money is invested by the manager of the user side, and that money goes to the pocket of the manager of the developing house. So the user side manager invests and developing house manager develops a software for the client, for the user. So these are the minimum 5 minimum. There will be quite a good number in between. So these are the 5 number of stakeholders who are associated with the software development process, and in between the role of architecture comes into the picture. Okay, role of architecture. So what it says, the stakeholders identify aspects of the system they are concerned about. What are the important aspects or the these are the major 5 important concerns we should not ignore. So they identify. Then they decide the relative importance of these concerns. Which one is more important, which one is less important. They bargain, they argue, they take a decision. They take a decision on the relative importance. Relative. This is, you see, there are some concerns, which one is more, which one is less. So it is identified. They are identified. Modeling depth should roughly mirror the relative importance of the concern. If it is more deep, then it is more important. Next. Okay, you may be feeling, okay, we'll see, Debabaya will be. So, as I was telling, the architect comes in between. In between means the manager and the developer. Developer is the person who develops a software as per the guidance of the architect. And architect gets the order from the manager of the developing house. So what the architect does, he identifies the basic elements in the architecture. For example, the bank consortium, he identifies what are the components, what are the connectors, what are the interfaces, what are the configurations, what is the rationale. Rationale means justification. I was telling in the use case diagram, why these many use cases? Is it really justified? Rationale, the 5th one, behind the decision. What is the logic? What is the justification? Rationale means logic or justification. Okay? So, this is the example of this thing we'll discuss later on in the next class. Just you see, the blue ones are the components, the pink ones are the stream or the connectors. I think the stream connector, which Pratik, it will help you. You have to explain that, okay?
Yes, sir. Yes, sir.
Yeah, these are the stream connectors, and how ports and roles are important. How do they play very important, significant meaning? Port and role, you see, one is port, one is role. So we'll talk in the next class. Just I gave some important initial little bit of push, because I wanted to show to Pratik how stream connector helps. Okay, we'll close it down. We'll close it down. Dear boys, be sincere. I'll be happy, because I try as much as possible to make you sincere. That is my objective of life, to make you responsible and sincere. That's all. Okay, we'll close it down. I assume that all are present today. Okay, bye. Bye, students. I'm quitting. Okay, we'll meet. Tomorrow is the lab class. Tomorrow is the lab class. And I think in the lab class, we have not yet done that component and interconnection diagram, right? We have not yet done. Have we done?
No.
Component diagram, have we done? No. Rahul? Rahul Sahu,
Yes, sir. Yes, sir.
component diagram have you shown for the bank
sir.
consortium bank? No, na?
No, sir.
So be prepared tomorrow. And interconnection diagrams, and there is an interconnection diagram. Jitendra Gora, मैं आपको बोला था, and आप 14 डायग्राम कंक्लूड कल करोगे जितेंद्र।
ओके
आपको कब से मैं बोल चुका हूँ।
राइट।
हाँ ये भैया